Okay, so it's already 6 o'clock. I am going to start the meeting. So, good evening. This is the eighth live discussion session of the NPTEL course Soil Mechanics Geotechnical Engineering 1. Uh, this is the problem solving session like the previous weeks. This week also has some numericals, MCQs, type of questions that I'll be first of all dictating to you all, and then I'll give you some time to solve those questions, and then I will start discussing the solutions to the questions I discussed. So in the previous class, I think the topic of shear strength had been discussed in detail, and in this class the compressibility of soils will be started, which will be continued further to the next live session. Um, that will be, I think, it has been preponed to the coming Saturday from 5 to 7. In that class, I'll be discussing some more parts of compressibility and consolidation and settlement of soils in those chapters. Okay, so I'll directly switch on to the PowerPoint presentation part. Yes. Is the PPT visible?
Yes, sir. Is it visible?
I think you are not audible. You can also comment in the chat box. I believe the PPT is well visible now. Sorry. So I'll just start, you know, dictating the questions. Okay. If you have any doubt, you can just yes, you can just mention in the chat box. I will discuss your queries. Okay. Okay. So I'll straight away go to the PPT and start dictating the questions. You can write down the questions or you can take a screenshot of the questions as is comfortable with you. And then I'll give you some time, 15 minutes, around 15 minutes, within which time you're supposed to solve the questions. And then after that, I'll be uh, discussing the answers. Okay. Please don't leave the meeting when you solve the questions. I'll be there in the meeting. I'll just start discussing in the same meeting itself. Okay. Fine. So the topic is compressibility of soils. And the first question is yes, the property due to which reduction in volume occurs under the application of load is called. The options are thixotropy, activity, compressibility, or sensitivity. I'll repeat the question. The property due to which reduction in volume occurs under the application of load is called. The options are thixotropy, activity, compressibility, or sensitivity. Okay. Next question.
Sir, your screen is not visible.
What are the major differences between compaction and consolidation? This is basically a very theoretical type of question, but this is very important because compaction and consolidation they generally have similar, methodologies, similar outcomes, but the specificities and the techniques and the overall procedure and the overall outcomes of the two processes are entirely different. Okay, so though there is similarity, there are also differences, and those differences are very significant. So, what are the major differences between compaction and consolidation? In the next slide, I have the answer. So, if you can just make two columns and write down the differences, and then tell me or drop one by one in the chat box the main the main gist, the main points of the differences. Okay, what are the major differences between compaction and consolidation? Okay, yes, next question. So I hope by now you are familiar with the procedure, the stages of consolidation, okay, in different types of soils. So the question is, in partially saturated soils, the initial consolidation is due to. In partially saturated soils, the initial consolidation is due to. The options are squeezing out of water from the voids. Option 2, expulsion and compression of air in the voids. Option 3, expulsion of highly viscous water. Option 4, none of these. I'll repeat the question. In partially saturated soils, the initial consolidation is due to option 1, squeezing out of water from the voids. Option 2, expulsion and compression of air in the voids. Option 3, expulsion of highly viscous water. And option 4, none of these. Okay, I hope the question was clear. I'll go to the next question. Yes. Consolidation of soils is due to load, which is due to load, which is option 1, static and short term. Option 2, dynamic and short term. Option 3, static and long term. And option 4, dynamic and long term.
This question basically means what is the type of load that can, make consolidation happen in soils. Am I audible? Hello?
Yes, sir, you are audible.
Okay, just a moment.
Just a moment, okay?
Go on.
Yes. Okay. Yeah. Sorry for the delay. My microphone got disconnected. Okay. So I'll just repeat this question. I hope you are there in the meeting. Yes. Consolidation of soils is due to load, which is option A static and short term, option B dynamic and long dynamic and short term, option C static and long term, and option D dynamic and long term. So these are the four options. Which kind of load mainly, you know, takes part in the process of consolidation. Okay. Next question. Yes. Consolidation mainly occurs in the following number of stages: 2, 4, 3, or 1. So whenever I'm talking about consolidation of soil, you have to remember one thing, that I'm talking about general soil, that is, what do you mean by general soil? Which is naturally available soil, which is always, partially saturated and not fully saturated or fully dry. Okay, because that is the extreme cases. In fully dry soil, consolidation will not take place because there is no water. In fully saturated soil, compaction might not take place. Okay, so I'm considering about the naturally available soil mass, which are generally, mostly, which are partially saturated. So in those kind of soils, consolidation mainly occurs in the following number of stages: 2, 4, 3, or 1. How many stages are there in the process of consolidation? That is the main question over here. Consolidation mainly occurs in the mainly consists of the following number of stages: 2, 4, 3, or 1. Okay. Okay, repeat the question once. Consolidation mainly consists of the following number of stages: 2, 4, 3, or 1. Okay. Next question. Yes. Secondary consolidation is mainly due to. Secondary consolidation is mainly due to. The options are: expulsion of highly viscous water. Option 2, plastic readjustment of solid particles. Option 3, both of the above. Or option 4, none of these. Secondary consolidation is one of the stages of consolidation. Okay. So what is the main, major phenomena that occurs in that stage? The options are expulsion of highly viscous water, plastic readjustment of solid particles, it can be both or it can be none. I'll repeat the question. Secondary consolidation is mainly due to first option expulsion of highly viscous water, second option plastic readjustment of solid particles, third option both of the above, or last option none of these. Okay? Okay. Next question. Yes. Which of the following is not an assumption in Terzagh's theory of one-dimensional consolidation? Which of the following is not an assumption in Terzagh's theory of one-dimensional consolidation? The options are soil mass is homogeneous and isotropic. Option 2, soil is fully saturated. Option 3, Darcy's law is valid. Or option 4, drainage of water occurs in both horizontal and vertical directions. I'll repeat the question once. Which of the following is not an assumption in Terzagh's theory of one-dimensional consolidation? Your options are soil mass is homogeneous and isotropic. Soil is fully saturated. Darcy's law is valid. Or drainage of water occurs in both horizontal and vertical directions. I hope the question was clear. I'll go to the next question. Coefficient of consolidation depends upon, your options are permeability, coefficient of volume change, unit weight of water, or all of these. I will repeat the question once. Coefficient of consolidation depends upon, the options are permeability, coefficient of volume change, unit weight of water, or all of these. Okay. Next question. Yes, this is a numerical. So write down the data very carefully. A soil sample which has been subjected to consolidation test has an area of 50 centimeter square. Dry weight of sample is 190.24 gram. Initial height of sample is 25 millimeter. Okay. Taking G equal to 2.67. G means specific gravity of the soil solids. G equal to 2.67. Determine the height of the solids and the initial void ratio of the soil. Determine the height of the solids and the initial void ratio of the soil. So here the sample, the area of the cross-sectional area of the sample has been given, the dry weight of the sample has been given, the initial height has been given, and the specific gravity of the soil solids has been given. Okay, the initial height has been given, so the height of the soil solids and the initial void ratio means the height of the soil solids considering the initial height that has been asked and the initial void ratio has been asked. I hope you have written the question. I'll just repeat once. A soil sample which has been subjected to consolidation test has an area of 50 centimeters square. The dry weight of sample is 190.24 gram. Initial height of sample is 25 millimeter. Taking G equal to 2.67, determine the height of the solids and the initial void ratio of the soil. Okay, I'll go to the next question now. Yes, an undisturbed sample of clay stratum 2 meter thick was tested in the laboratory and the average value of the coefficient of consolidation was found to be 2 into 10 to the power minus 4 centimeter square per second. Mind it, this is the coefficient of consolidation. Assuming double drainage, how long will it take to attain half the ultimate settlement under the load of a structure? So in this question, the time has been asked. You have to use the consolidation formula with respect to the time factor and the degree of consolidation. for this undisturbed sample of clay stratum. The thickness has been given and the coefficient of concentration has also been given 2 into 10 to the power minus 4 centimeters square per second. I'll repeat the question. An undisturbed sample of clay stratum 2 meter thick was tested in the laboratory and the average value of the coefficient of consolidation was found to be 2 into 10 to the power minus 4 centimeters square per second. Assuming double drainage, how long will it take to attain half the ultimate settlement under the load of a structure? Okay, I hope we have written down the question. I'll go to the next question. Yes. In consolidation testing, curve fitting method is used to determine. The options are compression index, swelling index, coefficient of consolidation, or time factor. I'll repeat the question. In consolidation testing, curve fitting method is used to determine. The options are compression index, swelling index, coefficient of consolidation, or time factor. I hope the question was clear. I'll go to the next question. Someone is joining now. Yes, those who are joining now, I have already started repeating the questions. So please write down the questions from here onwards. I'll give you some time to solve them. Afterwards, I'll discuss the solutions of all the questions. Okay. This is slide number 13. That means this is question number, I believe it's question number 11. Okay. I'll just repeat this question for the people for the one who have joined right now. Hitesh Chandra, yes. In consolidation testing, curve fitting method is used to determine. The options are compression index, swelling index, coefficient of consolidation, and or time factor. Which among these parameters can be found out using curve fitting method? Okay. If you know the answer, no need to write in the chat box or speak out. Just write down the answer. I'll give you time to solve the questions anyway. Okay. Next question. Yes. Which of the following soils will generally have maximum compressibility? Sand, clays, gravels, or silts? The topic of today's discussion is compressibility of soils. This is a preliminary discussion regarding compressibility, consolidation, and settlement. This is the first class to that chapter. Which of the following soils will generally have maximum compressibility? The options are sands, clays, gravels, or silts. I hope you know the differences between these four types of soils with respect to their grain sizes and other engineering parameters. So which among these will have the maximum compressibility? Okay, I'll go to the next question. Yes. If the coefficient of permeability is doubled and the coefficient of volume compressibility is halved, the coefficient of consolidation, what happens to the coefficient of consolidation? The options are increases by 2 times, decreases by 2 times, increases by 4 times, decreases by 4 times. I hope you know here you have to use the relationship between the coefficient of volume compressibility, permeability, and consolidations. I'll repeat the question. If the coefficient of permeability is doubled and the coefficient of volume compressibility is halved, the coefficient of consolidation increases by 2 times, decreases by 2 times, increases by 4 times, or decreases by 4 times. Okay. Next question. The delay caused in consolidation by slow drainage of water out of a saturated soil mass is called. The delay caused in consolidation by slow drainage of water out of a saturated soil mass is called. Your options are consolidation delay, hydrodynamic lag, pore pressure lag, or none of these. I repeat the question. The delay caused in consolidation by slow drainage of water out of a saturated soil mass is called. Your options are consolidation delay, hydrodynamic lag, pore pressure lag, or none of these. Okay. I hope the question was clear. I will go to the next question. Yes. During consolidation, as water escapes out, option 1, both neutral and effective pressures reduce. Option 2, both neutral and effective pressures increase. Option 3, neutral pressure reduces and effective pressure increases. And option 4, neutral pressure increases and effective pressure reduces. So what happens when water escapes out during the process of consolidation? I repeat the question. During consolidation, as water escapes out, both neutral and effective pressures reduce, both neutral and effective pressures increase, neutral pressure reduces and effective pressure increases, neutral pressure increases and effective pressure reduces. Okay. Next question. Yes. Curves indicating the distribution of excess hydrostatic pressure are called. Curves indicating the distribution of excess hydrostatic pressure, obviously it is inside a soil mass, they are called. The options are isobars, isochrones, isoheights, or none of these. I'll repeat the question. Curves indicating the distribution of excess hydrostatic pressure are called isobars, isochrones, isoheights, or none of these. Okay. Next question. Two identical clay samples of same sizes designated A and B are subjected to concentration tests under identical conditions. Drainage takes place through one phase in sample A and through both phases in sample B. 50% consolidation of sample A occurs in 10 minutes. Calculate the time required for 50% consolidation in sample B. So here there are two samples, A and B, same sizes, identical condition, everything is same. The only difference is that drainage is occurring through one phase, single drainage in the case of A, and in sample B, double drainage, that is drainage occurring through both phases in sample B. Now in the case of A, where single drainage is occurring, 50% consolidation occurs in 10 minutes. So for the case of B, where double drainage is occurring, how long will it take for the same 50% consolidation in that sample B? Okay, is the question clear? I hope the question is clear. I'll just repeat once. Two identical clay samples of same sizes designated as A and B are subjected to consolidation tests under identical conditions. Drainage takes place through one phase in sample A and through both phases in sample B. 50% consolidation of sample A occurs in 10 minutes. Calculate the time required for 50% consolidation in sample B. Obviously, drainage occurring through both phases, it will take much lesser time, but here the exact time is required. Okay, in sample B. I hope the question was clear. Can you see the yes? Okay, my video was not working. Okay, yes, I hope the question was clear. I'll go to the next question. This is the last question. Yes, a fully saturated clay specimen is subjected to a pressure of 200 kilonewton per meter square in the consolidation test. Determine the degree of consolidation after a period of time when the average pore pressure is 60 kilonewton per meter square. So here clay is as sample saturated subjected to the pressure of 200 kilonewton per meter square in the consolidation test. Now you have to find out the degree of consolidation when the pore pressure is 60. So the pressure, initial pressure was 200. Now when the pore pressure is 60 at that point of time, what will be the degree of consolidation of that clay specimen? Okay, I'll repeat the question once. A fully saturated clay specimen is subjected to a pressure of 200 kilonewton per meter square in the consolidation test. Determine the degree of consolidation after a period of time when the average pore pressure is 60 kilonewton per meter square. Okay, this is the last question. I believe there are approximately 19, 18 questions I have given you. Those who have joined later, there is no worries. Just do the solve the questions which I have given. So it is 18:51 right now, 6:51 p.m. I'm giving you 15 minutes to solve these questions. I'll start at 7:06 sharp. Okay, I'll start uh, discussing the solutions of these questions at 7:06. Okay, you can stay in the video call in this meeting. Yeah, sorry for the minor delay. I'll now start discussing the solutions to the questions. Okay, I hope you have solved. If you have not solved, no worries. I'll discuss anyway. Okay, so the first question was the property due to which reduction in volume occurs under the application of load is called. What is the answer? Any answer? Property due to which reduction in volume occurs under the application of load is called. Yes, compressibility. Rajavardhan Reddy Gupta. Yes, it is compressibility. Okay, so I'll just mark it as compressibility. And what are the other options now? So what is thigotropy? Thigotropy is the regaining of lost strength. It is the regaining of the lost strength with time under constant moisture content. When the soil regains its lost strength under constant moisture content, it is called thixotropy. What is activity? It is found mostly in clays, generally in clays. It is the degree of the moisture holding capacity of clays. Okay, degree of the moisture holding capacity or water holding capacity of clays. What is sensitivity? Sensitivity is the degree of disturbance that has been occurred in a soil due to remolding. Okay, sensitivity is the degree of disturbance. Okay, so these are the definitions of the other three options. In this question, the property due to which reduction in volume occurs under application of load, the answer is compressibility. Okay, it can be two types: compaction or consolidation. We'll see further in details. Okay, so this is the answer of the first question. I'll go to the next question. Next question was, okay, what are the major differences between compaction and consolidation? I think you know this and you have solved this. Anyway, I'm going straight to the answer. Okay, so this are the major, I'll not say all, but the major differences between compaction and consolidation. Firstly, in compaction, it is the compression of soil by the expulsion of air from the voids of the soil. And in the case of consolidation, it is the compression of soil by the expulsion of water from the voids of the soil. So in compaction, only air is expelled out. There is no scenario of water being expelled out. But in consolidation, expulsion of water is the main criteria of the entire process. Okay, so we can say so we can say that if we are talking about expulsion of water, then it might be possible that air has already been expelled out. Okay, Rajavardhan is saying compaction due to reduction in expulsion in air void and short term static. Yes, yes. We'll discuss this in further. So, if air is expelled out due to some load or compression in soil, it is called compaction. If water is expelled out, it is called consolidation. So, compaction is a quick process. Obviously, only air is being expelled out. So, it is faster. But the expulsion of water is a gradual process. Expulsion of water is a gradual process and it might follow the expulsion of air initially. So it is obviously the process of consolidation is a slow process. Okay. Short term loading is required in case of compaction and in the case of consolidation long term loading is required. Again short term loading is required because the expulsion of air does not require a gradual load to be applied. Okay. Short term sudden loading is enough for the removing of air. Big example is the standard Proctor testing. Okay, in Proctor testing, we give a specified number of blows with the help of a rammer to the soil for expelling out the air from the voids. Okay, in that case, the load is short term. Okay, 25 blows is enough for compaction. Whereas in consolidation, this is a long-term loading. It might be, you know, days after days, years after years might pass, and the consolidation process is occurring. Okay, so it is a long-term loading because the expulsion of water from the voice is a very complicated process and it takes time. Loading is applied in a dynamic way in case of compaction. Loading is static and constant in case of consolidation. Why dynamic? Because the intensity and frequency of the loading, it might vary, but that won't affect the process of compaction. In other case, in consolidation, the loading is static and constant. The same degree, same frequency loading, but for a longer time. For example, in the standard proto test, when we apply the load, okay, with the help of a rammer, we can never say if we are applying it manually that each and every time the intensity of the loading on the soil layer will be equal. Okay, in the first time I might hit it harder than the second time, or vice versa, but that will not affect the overall process of compaction. Okay, but in the case of consolidation, sudden loading will not cause the expulsion of water from the voids of soil. Okay, it is a static, that is, it is the frequency and intensity are not varying and it is constant in degree. That will lead to the gradual, by and by gradual expulsion of water from the voids into the soil. Okay, compaction is done purposely in order to get maximum dry density of soil. Consolidation of soil occurs naturally due to structural load from foundations. Yes. So in this case, we'll go directly to the next point also. It is done before the construction of the structure. Yes. So in the case of compaction, we know there is a graph of maximum dry density and optimum moisture content. Isn't it? This is a graph. This is the moisture content, water content. This is the dry density. So it goes like this. This is the optimum moisture content. This is the OMC and this is the maximum dry density. This is the MDD. Okay. So it is done purposely before the construction of the structure. Why? Because the soil below the structure should have the maximum dry density for proper transfer of the load from the superstructure to the substructure. Okay, if the soil is weak, then the foundation should not be preferable in that particular soil and hence the construction might get affected. So for any type of construction, if the soil is loose, we have to compact the soil to achieve the maximum dry density, achieve the maximum strength, so that the construction of foundation in the soil for proper transfer of the loads from the superstructure to the substructure is feasible. In other case, in consolidation, when the structure has been built, now a building has been built, the load from the structure is gradually, you know, affecting the soil mass, and now the gradual load, this is a slow process, this long term loading is causing gradually the expulsion of water from the voids of soil. So this happens naturally, this is not a manual process or done purposely. This happens naturally after any structure is built on the soil. Okay, because it is a long term process and it might require years and years of the static loading to have its effect on the soil. Okay, so these are the main differences between the compaction and consolidation. I hope it is clear to you right now. Any doubts regarding the difference between compaction and consolidation? All right, I will go to the next question. In partially saturated soils, the initial consolidation is due to. Okay, so in the case of partially saturated soil, so if you remember this three-phase diagram, this will solve most of the problems. This three-phase diagram, this is air, this is water, this is soil solids. This soil solids, okay. I'll just write solids over here. So this is a typical case of the partially saturated soil. Okay. Now in initial consolidation. Initial consolidation is one of the three phases of consolidation. In initial consolidation, what happens is at first the air gets expelled out. This is the first process. And this first process is called the initial consolidation. The first process is called the initial consolidation. So when the air gets expelled out, it causes compression in the voids. Okay, so compression of air in the void and expulsion. This is the answer. Whether this stage would have been present in the soil or not for fully saturated soil, that will go as we gradually move towards the next questions regarding the number of stages of consolidation and further things. Okay. So in partially saturated soil, the initial consolidation is due to what? Due to the expulsion and compression of air in the void. This is the first stage of consolidation. Okay. Again, consolidation of soil is due to load, which is, what is the answer of this question? Consolidation of soil is due to load, which is D. Dynamic and long term. Why dynamic? Does it need to change frequently for the consolidation to occur? The correct option is C, static and long term. See, I have mentioned here, no, in this, loading is static and constant in the case of consolidation. Loading is static and constant in the case of consolidation. So yes, the intensity and frequency of the loading is not varying. It's not like today a P amount of force is being there in the soil, tomorrow it has to be 2P, or and day after tomorrow it has to be 4P or 5P. Then only consolidation might occur. No. Okay. Loading is constant, static, and it is long term. That is the primary requirement of consolidation of soil. Okay. And if the loading it increases, just think of it, if the loading increases or decreases, then the process of expulsion of water, the intensity and frequency of it might vary, and that might lead to an interchange of the stages in consolidation, which will come later. So being in one stage of consolidation, making it happen fully, and then moving on to the next stage. For this, static and long-term loading is required. Okay, static and long-term loading is required. I hope this was clear. Next question. Consolidation mainly occurs in the consists of the following number of stages. Now I have mentioned consolidation, the process for this question. You have to consider that it is naturally occurring soil which is partially saturated. Okay. Now in this case, I'll again draw the three-phase diagram. I'll again draw the three-phase diagram which consists of air, water, and solids. Air, water, and solids. So in the first case, in initial consolidation, air gets expelled out in initial consolidation. Next, obviously, water has to get expelled out. This will be stage 2. Okay. And there is another stage, stage 3, which will be coming later in the next question. So this is initial consolidation. This is primary consolidation. And the third stage, number 3, this is called secondary consolidation. We'll discuss in the next question. Okay. So there are 3 number of stages in this process of consolidation for naturally occurring partially saturated soils. So the answer is 3. Initial consolidation, primary consolidation, and secondary consolidation. Initial consolidation is nothing but compaction where air gets expelled out only. Then when the air has got expelled out, water starts getting expelled out gradually. Okay. I hope the solution was clear. Any doubt? Okay. I'll go to the next question. Yes, secondary consolidation is mainly due to. So what happens is, here in the previous question I have drawn the diagram. This is the third stage, is called secondary consolidation. So when the water in the voids, they have got expelled out in stage 2, primary consolidation. Okay, there is some highly viscous water present, you know, along the surface of the soil particles or soil solids, which are extremely difficult to expel out. So when the loading it stays and continues for a long period of time and the water has got expelled out, then this viscous water from the from the soil particles, you know, between the soil particles, this highly viscous water, they start getting expelled out. And when this happens, when this highly viscous water between the soil particles, they start getting expelled out, there is a readjustment of the soil particles, which is generally plastic. Why plastic? Because when this rearrangement of the soil particles occurs, then after that, even if water is added to the soil, then the old arrangement will not be formed. The soil has permanently got deformed. The soil has permanently got deformed, or the solid particles have permanently got displaced. So it is called plastic readjustment. So in secondary consolidation, what happens? It occurs after the primary consolidation has occurred, in which the water in the voids have got expelled out. Now, in the third stage, in secondary consolidation, the highly viscous water on the surface of these solid particles, which are mostly on the surface, on the solid particles, they get expelled out, which leads to a rearranging or readjustment of the solid particles, which is plastic in nature. So secondary consolidation, it is mainly due to the expulsion of highly viscous water and plastic readjustment of solid particles in the soil mass. So the answer is both of the above. The answer is both of the above. Okay. Is the question clear? Is the solution clear? Any doubt regarding this? Okay. Right. I'll go to the next question now. of the following is not an assumption in Tarzagi's theory of one-dimensional consolidation? In the question, the answer was there itself. Tarzagi's theory of one-dimensional consolidation. So in one-dimensional consolidation, Tarzagi assumes that the loading is applied in one direction so that the drainage occurs in one direction, vertical direction, and not horizontal. If it occurs in both horizontal and vertical direction, then it will be two-dimensional consolidation. Okay, so since it has been said that Tarzagi's theory of one-dimensional consolidation, Tarzagi has assumed in this case that the drainage of water occurs due to loading in one direction only, and it is vertical direction. Coming forward, the numericals which you will see in there also, you will see the drainage of water in the soil is happening in the vertical direction and not the horizontal direction. Okay, in any way, if it is horizontal, only horizontal, that is towards the direction of the loading. Okay, if this is the soil sample, this is the soil sample like this, and the loading is like this. Okay, then the drainage of water will occur in this direction or both direction. Okay, again similarly, if this is the soil sample vertical, this is the loading like this or like this, drainage will occur in this direction or this direction or both. Okay, generally this is the scenario which is being shown in the laboratory testing and all those testing in the field, everything. The load is applied vertically, hence we say that the loading is vertical and the drainage of water occurs in vertical direction only. Okay, so this statement, drainage of water occurs in both horizontal and vertical direction. This is not an assumption in Tarzagi's theory of one-dimensional consolidation. Okay, this is the answer. Rest, soil mass is homogeneous isotropic. It is an assumption. Soil is fully saturated. Again, assumption in Tarzagi's theory of one-dimensional consolidation, and Darcy's law is valid. Yes, this is also an assumption in Tarzagi's theory of one-dimensional consolidation. Okay. I hope the solution was clear. I'll go to the next question. Yes, coefficient of consolidation depends upon. So coefficient of consolidation, the formula is Cb equals to, I think, K divided by Mv gamma W. So we can say Cb is a function of permeability, Mv, that is coefficient of volume change, and newton of water gamma W. So this is permeability, this is volume change, coefficient of volume change, this is gamma W from water. So coefficient of consolidation depends upon all the three. So all of this is the correct answer. Okay. Next question. Yes, have you solved this? Anyway, I'm solving it. Let's check the answer. Okay, so height of the soil solids, we use the analytical formula height of the soil solids as the weight of the soil solids, the mass, that is md, divided by g rho w into a. It is the density rho w, 1 gram per cc. Rho w is 1 gram per cc. Md is 190.24. Okay, so 190.24 divided by g is 2.67 into 1 into area per section is 50. What do we get? Just solve it once. Approximately 1.425. It is in centimeter or in millimeter. I will say 14.25 mm. So this is the height of the soil solids. Okay. Now the initial void ratio. So the void ratio, we know volume of void divided by volume of the soil solids. Volume of void divided by the volume of soil solids. So volume means area of cross section into height. So if the area of cross section is constant, then we can use height, only the height. Okay. So height of the voids. And what is the height of the voids? It is the initial height minus the height of soil solids. Will give us the height of the voids divided by the height of the soil solids. Okay. So we again solve this. 80 is 25. 80 is 25. And HS you have got. HS, yes, I think HS you have got 14.25. 25 minus 14.25 divided by 14.25. Yes, approximately 0.75, isn't it? 0.75. So the initial void ratio is 0.75. Okay, this is a sum from the laboratory testing. Next question. Okay, so just a moment. I think there is a glitch. I'll just open the PPT. Okay. Just a moment. Yes. Okay. So I guess there was a glitch. I'll just write it over here again. So this one was 25. This is equal to 0.75. Okay. This is the answer. This is HS. This is HS. Okay. Share the screen. Yes. Next question. An undisturbed sample of clay stratum 2 meter thick was tested in the laboratory. Okay, so here it has been stated that we have to assume double drainage. We have to assume double drainage. how long it will take to attain half the settlement. Now, for half settlement, that means U degree of consolidation is less than 60 degree because it is 50 degree, less than 60 percentage because it is 50 percentage. For which the formula for time factor TV equals to pi by 4 into U by 100 whole square. So U equal to 50 degree. For this TV, we obtain the value of time factor as approximately 0.197. 0.197. Okay, 0.197. Now, how long it will take to attain half the settlement? Okay, so for double drainage, D equals to H by 2, that is equals to 1 meter equals to 100 centimeter. Why 100 centimeter? Because the value of CV is given as centimeter. This is the value of CV. Okay, CV, coefficient of consolidation. Now, the time for 50% consolidation, that is equals to the time factor multiplied by D square drainage length divided by CV That means 0.97 into 100 square divided by 2 into 10 to the power minus 4. Okay. So now 0.197 into 100 into 100 into 1, 2, 3, 4 divided by 2. Okay, convert it into days. We have got the value in seconds. Convert it into days. Yes, approximately you will get as 114 days. 114 days. So in this question, the time taken for attaining half the settlement is 114 days. Okay. Okay. Next question. In consolidation testing, the curve fitting method is used to determine compression indices and swellingness and are determined by curve fitting method. The coefficient of consolidation, then the value of CV, is measured using the curve fitting method in the laboratory consolidation testing. Okay, the answer is the coefficient of consolidation. Next question, which is the following soils generally have maximum compressibility? Yes, the answer is clays, because clays are very easy to compress in the first place. The compaction is high in clay because of low particle size, high cohesion, and a greater deformability. And also clay has high activity, because of which it can hold water, a longer period of time than that in the coarse grained soils. So clay has the maximum compressibility. Next question is the coefficient of permeability is double, and the coefficient of volume compressibility is half the coefficient of consolidation. Okay, so here we have the formula CV equals to K by MV gamma W. Now we'll see that in the second case, if CV, suppose CV dash, what we have mentioned, coefficient of permeability is doubled, that is K becomes 2K, and the coefficient of volume compressibility halved. MV becomes MV divided by 2, and obviously nothing said about the permeant, so gamma w remains constant. So cv dash will be equal to how much? This 2 goes to the numerator, will be equals to 4 cv. cv is equal to 4 cv. So the coefficient of consolidation, it increases by 4 times. Increases by 4 times because k is in the numerator and mv is in the denominator. Okay, increases by 4 times. Okay. The delay caused in consolidation by slow drainage of water out of a saturated soil is called hydrodynamic lag. Okay, because of the gradual application of the load and the draining out of water, it is a very gradual process, and this delay caused in consolidation is called hydrodynamic lag. Okay. Next question. During consolidation as water escapes out, yes. So we know that total pressure equals to what? It equals to effective stress plus pore pressure, or effective stress is equals to total pressure minus the pore pressure. So as water escapes out, pore pressure will reduce. Okay, and pore pressure is also called neutral pressure. So it will be neutral pressure is reducing. So if this is reducing, okay, then this remaining the constant, effective stress, it increases. Effective stress is it increases. That is the grain to grain transfer of stress. Okay. So in this case, neutral pressure reduces and effective pressure increases. This is the correct answer. This is the correct answer. Okay. Next question. Curves indicating the distribution of excess hydrostatic pressures. Yes, the answer is isochrones. When there is excess hydrostatic pressure distribution in the soil, then we draw isochrone to denote the points having excess water pressure or pore pressure. Isobars are the line in the places having equal amount of pressures. Iso hat, same for the rainfall. Curves indicating equal rainfall. Okay, so here it is isochrones. Next question. Two identical samples of sizes is clear. Samples of same sizes is either A and B. Okay. So in this case, we can write like this. If it is same, so drainage path of A, if it is H, it is through one phase, single drainage. Drainage path of B will be H by 2, double drainage. Now we know the formula, time factor equals to CVT by D square. Okay, or time is equals to TV by CV into D square. In other words, time is directly proportional to the square of the drainage path. Okay, because it is the same sample, so TV and CV will be constant. So T equals directly proportional to D square. Now, time taken for A and time taken for B, if we give this in ratio form, it will be equal to how much? It will be equal to dA square by dB square, or dA by dB whole square. dA by dB whole square. Now dA is h, dB is h by 2, so it is 2 square, it becomes 4. So time taken for B will be equals to 1/4 of the time taken for A. Now, for the 50% consolidation, time taken for A is 10 minutes. So, for B, time taken will be 1/4 of 10 minutes. That will be equal to how much? Equal to 2.5 minutes. 2.5 minutes. Okay. So here we see that the time of consolidation is directly proportional to the square of the drainage length, drainage path. So in this case, time taken for B will be 1/4 of the time taken for A. That is 1/4 of 10 minutes equals to 2.5 minutes. Okay. Next question, this is the last question. Fully saturated clay specimen subjected to a cell pressure to a pressure of 200. Okay. So first of all, we'll see if this pressure is 200 at the point where we are asked to find out the degree of consolidation. The pore pressure U is 60. U is 60. So at this point, the effective pressure will be how much? It will be equal to total pressure minus the pore pressure. Minus the pore pressure. Okay. So in this case, it will be equals to 140. So 140 kilometer per meter square is the magnitude of the effective stress at the point when we are asked to find out the degree of consolidation. Now, for the final case, we know at the final stage when the consolidation will be over, then the final total pressure is 200. At the final stage, the water will not be there. Water will not be there. So the pore pressure will be 0. UF will be equal to 0. So the final effective pressure will be equals to sigma F minus UF, that is equals to 200 kilonewton per meter square. This is sigma dash F. This is sigma dash. So what is the degree of consolidation? Degree of consolidation is, what is the percentage of consolidation that has occurred now with respect to the percentage of consolidation at the ultimate stage, at the final stage. So we can also write degree of consolidation as in terms of the effective stress, that is at any point of time the degree of consolidation equals to the effective stress at that point of time divided by the effective stress at the ultimate final stage when the consolidation is over, that is into 100 in percentage. That is in percentage. There is also a formula for this where we can see that it is directly proportional, and the formula is, the formula of degree of consolidation, or it is not degree of consolidation, it is a settlement. Okay, MB del sigma into H. Okay, so if settlement is dependent upon the value of sigma, obviously the degree of consolidation will also be dependent on the value of sigma, or the value of the effective stress. Value of the effective stress, because the degree of consolidation is nothing but the ratio of the settlement at one point of time to the settlement at the ultimate stage. So if settlement is given by rho, then rho T divided by rho F, that is the initial settlement minus the final settlement divided by final settlement, will give us the value of the degree of consolidation. Okay, value of the degree of consolidation. Just a moment, I'll just check the initial formula once. Yes, del, this is the settlement or the change in the thickness. It is equals to mv del sigma into h. mv del sigma into h. Okay, so in this case, the degree of consolidation after a period of time will be equal to the effective stress at that point of time divided by the effective stress at the ultimate stage, into 100%. So all you have to do is 140 divided by 200 into 100 percentage will get a value of 70 percentage. 70 percentage. Okay. So this was the last question. Just a moment. भाई भाई अरे भाई तो 2 दिन तो लिखा हुआ है तो तूने जगह ऑक्यूपाई करके सेव कर लिया है कि वो अरे कोई नहीं ये क्या है ठीक है ना ये कर रहा Okay, so this was the last question. I hope the solutions were clear. So sorry for the little delay and inconvenience. Thank you for attending the class. We'll meet again in the next class, probably on Saturday, with the next part of the consolidation. Okay? Thank you.